Academy. Today we want to look at a topic in neural analysis called limits of a functions Sn as the x tends to. So if you have not subscribed to this channel, kindly subscribe and also share with your friends about this. So therefore, welcome. So we are looking at limits of functions as x tends to a given point A. So a function f is bounded if there exists a given m and a capital M such that m is less than this. Where we had just mentioned from my previous tutorial about this, and we say that small m stands for lower bound and capital M stands for upper bound of the function respectively. They said the supreme of f is m, and if mum of that f is small m. So limits of a function as x tends to a given point A, we let f be a function defined on some neighborhood n of a point. Then f which is the function, is said to tend to a limit L as x tends to a point A if for each given positive epsilon there exists a delta which is positive delta, such that the function, part of function, the derivative of the function and the limit are less than that epsilon given. Whenever you find that x, the of x minus 1a is less than a given delta, So you are saying this one, x minus a less than delta, implies that f of x minus the limit is less than the epsilon. Note that it's always, we do this by having a limit of fx extend to L, x to L, result tends to fx tends to L, and sx tends to a point A. So that's the basic definition of a function. So remember, there must be a given epsilon which is positive, okay, and then the function here, this giving a function minus the limit here should be less than epsilon, and this will happen only and only if there is this one is true, that x minus that is less than a given delta, is less than a given delta. So if that conditions are okay, that you say that the limit of that function. A remark: in order to show that f does not tend to a limit, in order to show that f does not tend to limit L as x tends to a point A, is sufficient to find a given positive epsilon such that the delta, each delta, a positive delta of some x, which is a real number for which this one x is less than delta, but you find that in the other condition is not satisfying, that the function minus the limit is greater than epsilon. Remember, if for this to be a limit, then this should be less than epsilon, but if it happens to be the opposite, then we say that that one is not the limit of that function. It's not the limit of that function. So for example, we want to show that this one equal to half Okay, the limit of this function here is as x tends to 1 is actually half. We want to show that. So what we need to do is basically we have the conditions. So the first condition is that you take the function minus L, and this one we want to show that it's less than the epsilon. Whenever x minus 1 is less than the delta for all positive delta and positive epsilon. So our function here is actually this minus half, which is less than the epsilon. What you need to do is just to work out now. Let's work out for this. So if you solve this by normal expansion, you'll find that our x minus 1 is less than this, okay, which we can choose this now to become our delta following as by the definition of limit, so that this one will imply this is true, by that one is true, and therefore our function minus limit is less than epsilon whenever this is true. And because the two conditions of limit have been satisfied, and of course our epsilon is positive, in this case, we say that truly half is the this half here is the limit point of that function. So that's basically what you need to reason out. Okay, so kindly subscribe if you have not subscribed. Share also with your friends so that every time I post a new thing here, you get notification. Okay, bye until next time.